We're going to do two worksheets today. The first one is the step function worksheet. So this one. If we read this first paragraph, Jack and Jill were told to load 2 trucks with water. Jill has placed a large water container in the truck and stuck a hose in that can fill the container at 1 gallon per minute. Jack would like to showcase his strength, so he's decided to fill the truck with 1-gallon jugs full of water. But when he fell down and broke his crown, he also hurt his back and one of his arms, so he can only put 1 jug on the truck every minute. Okay? So, so what's the difference between these two stories? What's different about them? Good job. Okay, mathematically, what's the difference? They're both linear. They're both 1 gallon per minute, right? So if they're filling the truck at the same rate, what's the difference? So if we were to graph Jill's graph, it would be continually filling up. What is Jack's story going to look like? What's that? Oh. Okay, is it just dots? So for sure, it's going to fit this linear dot pattern. But if all we did was graph the dots, then if we go to x equals 1/2, how much is in the truck? Well, according to that graph, nothing. So it's not quite dots. It's steps. It's a step function. So there are dots, but then there are also these lines. Now, on the right side of those lines, what should I put? An open circle. I don't want to put it straight up because then it would cease to be a function. Functions can never be perfectly vertical. Okay, so Jack's putting 1 gallon at a time, and while he's running over grabbing the other gallon, there still is stuff on the truck. Okay? Excuse me. So what is Jill's equation? What's the linear equation? Y equals x, or 1x plus 0. So Jill's equation is x, and Jack's equation is what we call the greatest integer function. And the greatest integer function is given by this double bracket. Sometimes certain books and tests use a single bracket, but most of the time it's a double bracket. Okay? Well, if you were to describe what the greatest integer function does, how would you describe it? How would you turn Jill's graph into Jack's graph? What's happening? Well, let me give you a hint. So x, y. If I plug in 1, what do I get out of Jack's function? 1. If I plug in 2, what do I get? 2. If I plug in 2.5, what do I get? 2. How many gallons are there at 2.5 minutes? 2, because he hasn't put the third one on yet. Right? So what about 3.1? 3. 4.9. 4. So what's happening? Okay, good. Is there another way to think of that? So if I told you a number, say x, what are you going to do to that x value? No, so, well, if I told you 8, the answer would be 8. If I told you 9.5, then you would tell me 9. But if I told you x, an unknown value, what should I do to that unknown value? Round it down to the nearest integer. What? That's exactly what we did, was rounded it down. You told me 2.5, I rounded it down to 2. You told me 3.1, I rounded it down to 3. That's what the greatest integer function does. It rounds it down to the greatest integer less than whatever it is. So rounds it down to the nearest integer. So that's the explanation of what the greatest integer function does. It always rounds down. So if it is an integer, you leave it where it is. If it's not an integer, you round it down to the nearest integer. Okay? So, so here we have 0.5x plus 1. So 1/2 x plus 1. So that touches the y-axis at 1, up 1 over 2, up 1 over 2, up 1 over 2. That's the graph of f of x. Now, just for your information, there are two types of integer functions. The greatest integer function is referred to as a floor function because it rounds down. A ceiling function rounds up. Okay? But I know it's called the greatest integer function, so you might think that that means round up, but it doesn't. It's the greatest integer less than or equal to the given value. So the integer function and the floor function are the same. But, well, if you said the lowest integer less than or equal to what you have, that would be negative infinity every time. Because it's the biggest number less than what you have. If you said the smallest number less than what you have, it would always be negative infinity. So, yeah, it says round down, lower the value until you hit the integer. Okay? So, sometimes they'll give the floor function this symbol, an incomplete bracket where it has feet as a floor. The ceiling function sometimes is given like, well, it's always given like that. So, all you need to know really is the floor function. After the next 3 minutes, you'll never see the ceiling function in this class again, but you might see it somewhere else. So that's why I threw it in. So if I took those points, so if I draw the points, oh wait, they need to be up a little bit higher. Okay, and I'm rounding down, the function would look like this. What would the ceiling function look like? It would be 1 unit higher, and notice that the filled in circles are on the right. So the open circles are on the left, whereas on the other graph, the open circles are on the right. Your calculator will not graph a ceiling function. You could take a floor function and add one to it, and it would look like the ceiling function, but the endpoints would be wrong. Okay? So, to graph a ceiling or a floor function, go into y equals, clear out whatever you have, and the greatest integer function is in the same place as the absolute value function, and it's the int. So go to math, over to number, and number 5 is the integer function. So we could graph the integer function of x. So some of you will get a function that looks like this. Oh boy. Sorry. See how it connected the dots? So one thing you can do is go into y equals. And then over here on the left side, you can pick the style of graph. So go over to where it says straight line, and just keep hitting enter until you get to the dotted line, which is near the end. Actually, it's the last one. And then regraph it. Now it graphs it as a series of dots, and those vertical lines have disappeared. Yeah, if it actually looks like a staircase, that's with those vertical lines, that's wrong. And if you don't mind, it doesn't really matter. As long as you know that they're not there, it doesn't really matter. I don't know where yours is. No. No. Should say integer. Can you just skip right to I? I don't know. Okay, so if I wanted to graph these 0.5x plus 1s, there's a difference between the integer function of 0.5x plus 1 and 0.5 integer of x plus 1. That might work. Give it a try. Yes. So there are two ways to do the integer function. One way is to put everything inside the integer function. The other way is just to put the x inside the integer function. Okay? The first one calculates the function and then creates an integer. The second one creates an integer and then plugs that integer into the function. Okay? So in the first one, I perform that calculation and then I spit out the integer. On the second one, I find the integer and then I cut it in half and then I add 1 to it. Okay? And in general, the way I remember it is these brackets are bigger, so the graph will be longer. These brackets are smaller, so the graph is going to be in small steps. And here's what I mean. So let's say that Jack was putting 2 jugs on the truck at once. Well, two jugs on the truck per minute. Well, there are 2 ways to do that. He could carry 2 jugs and stick them on at the same time at the end of every minute, or he could put 1 jug on the truck every 30 seconds. Does that make sense? So one graph would look like this. One graph would be no jugs, 2 jugs, 4 jugs, 6 jugs. And the other graph would look like this. It's the same line. So you see, this is the line 2x, and this is also the line 2x. The difference is, on the first one he's putting 2 at the same time. On the second one he's putting 1 at a time every 30 seconds. Okay? And the easy way to remember it is the longer the line, the wider those brackets go. So this one would be bracket 2x, and this would be 2 bracket x. And you need to know the difference, because depending on what the story says, you put the x in the brackets or the whole function in the brackets. So if you want longer steps, then you put everything in the bracket. So you need to know, is it 1 at a time, or is it a bunch at a time, 2 or 3 or 4, whatever at a time. Okay? So, and you can see that, I'll just graph these for you. So if I had the integer of 0.5x plus 1, oops, that should be inside. And I graph it, see how long those steps are? And if I change it to 0.5 integer of x plus 1, it's the exact same slope, but those steps are now smaller. Okay? All right, turn the page. The big bad wolf decided that blowing houses down is not nearly as fun as blowing houses up. Man, I like this guy more and more every day. Right now, there are 15 little pig houses on his hit list. He prefers to blow up 3 houses at a time, and it takes him an hour to set the charges. Create a step function and equation for the number of little pig houses. Okay? So how many houses are there right now? 15 houses. Okay? And we need to decide, is this step function going to have long sections or short sections? Is he going to do 1 at a time, or is he doing 3 at a time? 3 at a time. How do you know? It specifically said 3 at a time. Okay? Instead of blowing up 1 every 20 minutes, he's blowing up 3 an hour, which is the same rate, but it changes the graph. So I'm going to go over here, there, there. Okay. Now, the other way to do this would have been a bunch of short lines, but we decided that's not the case. That red line represents blowing up 1 house every 20 minutes, which accomplishes the same thing, but the graph looks different. So if that's the case, should I put the whole function in brackets or just the x in brackets? The whole function, because we have long graphs, so we need wide brackets. So what is the equation here? How many houses is he blowing up per hour? So negative 3x plus the y-intercept is 15, and I'm going to put that in greatest integer. So if I were to graph that, I would do the greatest integer of negative 3x plus 15. Oops. 3x plus 15. And then close the parentheses. And I need to change my window. I need my window to match this. So the x's are from 0 to 6. And the y values are from 0 to 15. Oh, what did I do wrong? 3x plus 15. Oh, please don't tell me I've been teaching you wrong the whole time. Oh, man. Integer of x plus 15. Oh. Oh, I know what's going on. Okay. Backwards. I told you backwards. So in this case, if you want the longer lines, then you have to switch to the smaller brackets. So negative 3 greatest integer of x plus 15. Sorry about that. Okay, so when will the big bad wolf run out of houses? No. 5 hours. Right? Because that represents blowing up the last 3 houses. This stuff represents the charge setting for blowing up 3 more houses which don't exist. So really the graph stops right there and he's done. So if you were to do the domain of this, it would be from 0 to 5, and it doesn't go past 5. Okay, next one. Humpty Dumpty didn't actually break when he fell off the wall. In an attempt to fulfill his part of the rhyme, he climbed back up on the wall and fell off again. So far, he's fallen off the wall 8 times. It takes him 4 minutes to climb back up on the wall so he can fall off again. So, this graph, where are we going to begin? At 8. So 8 How long does it take him to fall off the wall the next time? 4 minutes. So there, and there, and there. Okay. So is this going to be short lines or long lines? This will be long lines because he's not going to fall off 1/4 of the wall, right? So he's going to go all the way to the top and fall, and all the way to the top and fall, and all the way to the top and fall. So the slope is 1 fall every 4 minutes, starting with 8. So should I put the x in brackets or the whole thing in brackets? Just the x. So 1/4 x plus, 1/4 math integer of x plus 8. And there it is. No. Okay, this is where the problem is. So I'm not actually going to test you on the whole long and short thing. And the trouble is here, if you're going up by a fraction, then the rules flip. So, oh no, that's right. I'm just zoomed out. Okay. So if I plug in second calc value, if I plug in, let's say 3, yeah, I figured that was going to happen. So if you're changing by a number bigger than 1, then the whole bracket the x or bracket the whole function is one thing, and if you switch to fractions, then it goes the other way. So it's a little more complicated than I originally expected. Hey, I'm still new here. So you'll just have to graph it and figure out which is which. But in this case, you'd want to bracket the whole function. Yes? Okay, I'll come look at that in a second. Okay. John Bob the Frog has been, oh wait, when did the nursery rhyme begin? 32 hours ago, minutes ago, 32 minutes ago. John Bob the Frog has been trying to get girls to kiss him so he can turn into a prince. While he does attract a lot of loose-lipped women, he never actually makes a transformation. Oh, poor frog. From the start of his quest, he receives 2 kisses per minute at regular intervals from different girls. Create a step function, graph, and equation for the number of kisses John Bob receives. So are these going to be long lines or short lines? Short, how come? Right. As much as he wants to, he can't kiss 2 girls at once. So he kisses a girl every 30 seconds. So this will be short. So the function is going to be 2x. So the function is 2x, and it's going to be, oh man, there we go. So nothing, 1, it's going to look like this. And I know this is kind of a guess for you guys, but should I put the x in brackets or the whole thing in brackets? Now that I've thoroughly confused you. Let's try it. So, come on. So if I did 2, let's see if I understand this. I think this is not correct. Yeah. So it should be the x in brackets. I put the x in brackets. And it should be the whole thing. So it should be 2x. And again, that's kind of confusing because for fractions it works one way, and for non-fractions it works the other way. But there are the half steps. So if you ever run into a problem like that, I would just scrap the rules and graph it one way. If it doesn't work, then pick the other way. Okay? All right, your assignment tonight is the second worksheet. The second worksheet, you just have a bunch of greatest integer functions. Just type them in as they are and then graph them.